Now let us define the curvature of a curve at a point P. So consider a curve C. Let A be a fixed point on the curve. Let P be a variable point on the curve. Let Q be a point in the neighborhood of point P. Let the arc length between P and Q measured along the curve be equal to delta S. Draw a tangent to the curve at point P which makes an angle psi with the x-axis. Draw a tangent to the curve at point Q which makes an angle psi plus delta psi with the x-axis. Then the angle between the two tangents is equal to delta S, because we know that the exterior angle is equal to sum of the interior opposite angles. So therefore the angle between the two tangents at point P and Q is equal to delta S. So delta S is called as the angle between, it is the angle between the two tangents, which is also called as the bending of the curve. So delta S is called as the bending of the curve, which depends on the arc length delta S. Hence delta psi by delta S is the ratio of bending of the curve between the points P and Q and the arc length between them. So now the rate of bending of the curve with respect to the arc length to the curve at point P is called as the curvature of the curve. The rate of bending of the curve at point P to the curve with respect to the arc length is called as the bending of the curve, which is denoted by the letter K, which is also called as kappa, and hence we can define the curvature of the curve K is equal to d psi by ds, which is equal to limit Q tending to P of delta psi by delta S. So now if this curvature of the curve at point P is not equal to 0, then we can find its reciprocal 1 by K. It exists, and hence that 1 by K, the reciprocal of the curvature, is called as the radius of curvature, and radius of curvature is denoted by the letter rho. So rho is equal to 1 by K, which is equal to ds by d psi. So this is called as the radius of curvature. Now the sign of the rho or K, that is the sign of the curvature or the radius of curvature, determines the convexity or the concavity of the curve. But usually in the problems we take the curvature or the radius of curvature to be positive. Now what does this geometrically mean? Now let us consider this curve, and we have taken a point P. Draw a circle with center O and with radius OP, which touches, this circle touches the curve only at point P externally, and hence this circle which we have drawn, the circumference of this circle is called as the circumference of the curvature, and the center of the circle is called as the center of curvature, and this radius of the circle is called as the radius of curvature. So this is the geometrical meaning of the radius of curvature.